Hello again everybody, Supergroup 3 reporting back to make sure you don't miss anything we have done since our last encounter. Remember? 3 crazy young companies with more or less different business models in the online movie domain merging into one. We already told you about the specific challenges of matching and mapping our different database schemas and showed you the resulting mediated schema. A few minor changes have been done to it since. It still consists of 3 parts. The green one contains the customer, rental and payment system, mainly derived from Couch Cinema. The blue area consists of the detailed movie data structure of BDMI, including the edition system of Dolly Blockbuster. Last but not least, the orange part displays the inventory system derived from Dolly Blockbuster as well. Changes are displayed in yellow. The first thing we had to add is a movie mapping table. The table contains the IDs from the different sources from which we will import movies later on. To improve the appearance of the graphical web interface, the column poster has been added in the movie table, and the fields poster and biography have been added in the person table. In the movie table we also added the production country of the movie to enhance reports with Google Fusion tables, but we'll look at that later. There were also a few minor changes in the edition and customer table, but let's have a look at how we populated the schema. We implemented a program that contains a number of data generators that connect to public APIs on the internet to fetch and combine data and insert the outcome into our database. Custom modifications and add-ons complete the package. Let's look at a few examples. To gather data for all movie-related tables like movies, movie genres, movie cast, directors and writers, as well as movie editions, we did not focus on one API in particular, but exploited the best features from 3. The sources we used were the MovieDB, which is an open-source database for movies, Rotten Tomatoes, which is well known for their big community giving ratings and reviews, and Rovi. The latter is providing entertainment meter data on movies to online distributors and other entertainment portals. Since we are an online distributor, we are allowed to use the Rovi metadata API. We could have worked with only one API, but each of them has its own pros and cons. For example, the MovieDB gives detailed personal information like birthday, biography, and a profile picture for each person in a movie cast, where Rotten Tomatoes only supplies the actor's name and the role he plays. The other way around, Rotten Tomatoes has a huge movie reviews database with detailed review comments, whereas the number of reviews from the MovieDB is very small. Rovi is the only vendor which gives us a description for genres, so we use this API to fetch genres. Moreover, Rovi is the only one which gives us information about the different editions of a movie, like Blu-ray or Special Extended Cut. Since we are receiving movie information from different APIs, we need to match the incoming data by their movie title in order to prevent duplicates and to add the right data, like the ratings, to the right movie. For this use case we employed the well-known Jacquard measure and enhanced it by our own domain knowledge. First of all, we removed common stop words. Movies like The Fast and the Furious can be written with or without the leading the, and the and can be written as the word or as the and sign. By removing these words, we only keep the relevant elements of the strings. Moreover, some APIs enumerate movies that are part of a series with Roman numerals, whereas other APIs use Arabic digits. We convert the Roman numerals from 1 to 12 into Arabic digits. At the moment, the movie titles are still strings. It's time to tokenize these strings and to get an array of n-grams for each string. These arrays are used to calculate the Jacquard similarity. In most scenarios we would be finished here. In our domain, however, we still have one less step to do. We want to prevent the algorithm to match sequels like Iron Man and Iron Man 2, so we give special attention to the last character of the strings. If one or both strings end with a digit, we compare these last characters. If they are not equal, we assign a penalty to the similarity score. To fetch data which is related to movie contributors, such as actors, writers or directors, we use the APIs of TMDB and Rotten Tomatoes. The function we implemented for this purpose allows us to specify how many persons should be generated from the Rotten API. Due to it offering more comprehensive information, the TMDB API is our primary data source. As part of the generation process, the relations isActor_in, isWriter_of, and isDirector_of are populated. For each actor playing a character, a role and a place role record are created. The TMDB API route for movie credits takes the movie ID as parameter, which we extract from our mapping table. The response is a JSON object containing an array named cast, which contains actors and their related characters. Directors and actors are stored in a crew array. Additional information as birthday or biography require another request for each person. As this information is not part of the initial response and TMDB does not provide any parameters for further population. For the sake of having a better performance, these requests may be skipped by setting a parameter in our application to false. The Rotten Tomatoes API does not provide details about directors or writers as part of its movie credits route. Still, the cast is stored in a similar way as known from TMDB. As before, persons are only generated for movies that have a Rotten Movie ID in our mapping table. The data for our customers we received from the website fakenamegenerator.com. This site allows us to specify some characteristics of the generated customer. For instance, the origin of the generated name, the origin country of the address, the range of the generated age, and the probability that the generated person is male or female. Based on those settings, the fakename generator creates a person which includes, among other attributes, a first name and a last name, an address, an email address, and a clear text password. Taking a closer look at the output HTML code of the fakename generator website, which is partly shown on the slide, we find all provided attributes of the generator, like for example name, address, or email address embedded. We can now use regular expressions to extract attributes out of the provided HTML markup. In order to do so, we use the function pragmatch, which supports searching for a given regular expression in a string and saving the results into an array. Let's have a look at an example on how to extract a certain attribute like the email address of a generated person. To retrieve the email address with a regular expression, we can use the expression in the pattern variable. The symbol tilde is just a delimiter that is required to separate the expression itself from modifiers that might follow it, like for example for case insensitivity. The following list item and span HTML snippet determines the beginning of the attribute email address. Since we don't want to validate such an address, but rely on the fakename generator, we use a simple non-greedy expression to extract it. It is delimited by the closing span tag. With the help of the pragmatch function and the stated regular expression, the respective email address is now persisted in the array match array. The complete expression used for the extraction of all required attributes is quite complex and we don't want to bother you with it. We also tried parsing the HTML markup using different libraries, but we encountered significant disadvantages in speed, which were especially noticeable when generating a high number of customer profiles. Now that we've got all these fresh data records, we would like to make them visible to our staff. Some statistics based on this data were also requested by our executive board. Experience has shown that we cannot trust them with SQL. That's why we implemented a web application that offers a convenient overview. As a technical basis, the Slim framework provides the basic structure of the application. We also use the Idiom and Paris Object Relational Mapper framework that converts records from the database to PHP objects and vice versa. Views are created using the templating engine Twig and Twitter Bootstrap for design purposes. Charts are visualized using the Morris.js library. But enough of these technicalities. Let's dive in. Here you see the dashboard. It's the starting point and offers an overview of our recent activities, as well as a chart describing rentals and turnover of the last 12 months, or one that shows us how our movies are distributed across the various genres. The system also determines an average customer. He is a 43-year-old male that rented movies from us around 14 times. His favorite movie apparently is Zombieland. No wonder, have you seen that piece? Let's peek at a list of all our movies. Most of these list overviews also offer some useful statistics concerning the respective entity type. You can even change the time scope. Now let's look at the specific movie. These detail pages, they not only display the object's attributes, but also lists with connected elements, such in this case actors, ratings, or editions. Everything is of course connected via hyperlinks to guarantee an intuitive navigation. Nice, right? Now, you've already seen a little bit of visualized data in our web application right there. But there are of course other ways to do this. Google offers a powerful tool called Google Fusion Tables that allows us to combine data queried from our own system with such of other public sources to answer interesting questions about our business. Let's have a look at some examples. Given us the following question: does our database already contain all movies our most active actors starred in? Well, therefore we counted the number of movies for every actor in our database. The displayed table shows the most active ones. Bill Nighy seems to be in the lead here regarding our database. Now we want to compare these figures to an external source provided by Wikipedia. If we merge these tables over the actors' names and only select the columns actor names and amount of movies from the internal and also external sources, this leads us to the following table. In order to compare these figures, we choose a bar chart representation in which the y-axis shows the actors and the x-axis the respective number of played movies. The displayed bar chart points out two different aspects. First, it becomes obvious that the external data source does not contain all of the actors our database holds, e.g. our most diligent one, Bill Nighy. Furthermore, the displayed number of movies differs a lot between our database and the external source, which answers our beforehand stated question. Our database does not already contain all movies our most active actors played in. That's a bummer, but we'll work on that. Anyway, let's look at this question. How is our turnover distributed among Germany? We extract the turnover per region from our database. As a result, we have the following table. In order to show the different regions of Germany, we need a public Google Fusion table, which contains geometrical data for all of these regions. We can merge the tables using the names of the regions. This is the resulting table. We now have the turnover per region and the geometrical data in one table. Google allows us to create a map for this data. We color the different regions depending on their turnover. A legend shows which color corresponds to which range. Let's examine one last question we'd like to answer using Google Fusion Tables. Are there any genres which are preferred by a specific gender? The gender distribution for each movie genre is a valuable indicator for our business, as it empowers us to create gender-related advertisements and suggestions. We'll spare you the details of the creation process for this network graph, since it wouldn't differ that much from the previous examples. Although the gender is almost equally distributed among our customers, the amount of rentals from our male customers is with around 1,500 significantly higher than rentals from our female customers, which only counts to 1,200. Therefore, the data has to be evaluated with caution. Nevertheless, it's evident that action movies are more likely to be rented from a male customer. In the network graph, the related edge is accordingly thicker than the edge from the female node. Alright, this already brings us to the end of our presentation. We hope you got some useful insights and thank you for your attention. Speak to you again soon. Oh, or maybe not. Anyway, have a great life. Bye bye.